All right, let's get right into it. Today we are talking about a totally radical new idea about, well, everything. What if I told you the entire universe, the whole shebang, could be boiled down to just a single line of code?
It all kicks off with a question that seems so obvious we never even think to ask it. Why can you remember what you had for breakfast yesterday, but you have no idea what you're going to have tomorrow? This one-way street we call time, it's one of the biggest, most stubborn mysteries in all of physics. And here's where things get really weird. Our most successful theories, Einstein's general relativity, quantum mechanics, their equations don't care about time. They work perfectly whether you run the clock forwards or backwards. But just look around. In egg shatters, it doesn't magically reassemble itself. The universe is expanding, not shrinking. Our fundamental laws seem to be totally out of sync with the reality we see every single day. So what if we've been looking at this completely backwards? This is where the time force hypothesis, or TFH for short, comes in and flips the whole script. It says, what if the arrow of time, this one-way flow, isn't some weird side effect of bigger things? What if it's the fundamental rule of nature? Okay, to really get a handle on this, I want you to picture something. The theory asks us to imagine the universe as a vast, constantly flowing river of energy. Just hold that image in your head. Everything we see, every particle, every star is just a pattern, a little swirl in this giant cosmic river. So here's the absolute key to the whole thing. This river, it's not perfect. It's got a little bit of friction. TFH proposes that every single movement, every flow of energy is constantly being damped or slowed down by a tiny, constant amount. Think of it like a universal drag. And this isn't an accident. It's the default state of everything. And that tiny drag is what creates the arrow of time. And believe it or not, this entire mind-bending idea can be captured in a single equation. You can really think of it as the universe's source code. And the most critical new piece of that code is the term that adds this rule, that everything, everywhere, damps. That's the built-in friction that this theory says is running the whole show. Okay, so a single rule is one thing, but how in the world do you build an entire universe from it? Well, this is where the theory makes its most profound and, frankly, its most mind-blowing claim. It connects that tiny, microscopic drag to the largest thing we know, the entire cosmos. The value they calculated for this universal damping is, well, just look at it. It's ridiculously small. It is a drag so incredibly faint that you would never ever feel it or notice it in your daily life. It's like the quietest whisper in the background of the universe. Now that tiny flutter, that quiet whisper, is what governs how energy fades and how quantum states decay at the most fundamental level you can imagine. It's the rhythm of time itself, ticking away deep inside the quantum realm.
And now, get ready for the big reveal. That exact same number, that tiny, microscopic beat, is identical to the Hubble constant. Yeah, the measured rate at which our entire universe is expanding. According to TFH, this is absolutely not a coincidence. It's the whole point. It's what they call the keystone identity. It means the microscopic arrow of time and the macroscopic expansion of the universe are literally the same thing. The universe has one single heartbeat, and you can feel its rhythm in the decay of a single atom and in the stretching of galaxies millions of light years apart. Okay, that's a wild idea, right? So if we accept this, that one rule connects the quantum and the cosmic, the next big question is, how does it actually build anything? How do you get from a river with a bit of drag to stars, planets, and us? Well, the way it unfolds is actually pretty elegant. It's a cascade. So step one, you've got that universal damping, that little bit of friction in the river. That drag is what allows tiny, stable whirlpools of energy to form and hold their shape. Bam, you've got particles. So what do whirlpools do? They disturb the water around them, sending out ripples. Bam, you've got forces. And finally, what happens when you have billions and billions of these whirlpools and ripples all interacting? The whole river starts to drift. And that large-scale drift, that's what we experience as gravity. So, the theory can build a universe, on paper, but the real test for any new idea in physics is, can it solve the problems that are stumping everyone else? Can it shed some light on the biggest puzzles we have, like the whole dark side of the universe? Let's break down the difference. Take dark energy, the stuff that's making the universe expand faster and faster. The standard model says it's some mysterious, unknown energy. TFH says, nope, that's just our universal damping doing its thing on a cosmic scale. And what about dark matter? Physics has been hunting for some new invisible particle for decades. TFH suggests it's not a particle at all. It's just the drag, the damping, getting a little bit stronger in dense places like galaxies, which creates an effect that looks exactly like there's extra gravity from some invisible matter. No new stuff needed.
Now, this all sounds like a really neat story, but a good story isn't the same as good science. And here's the coolest part. This isn't just some philosophical idea. The theory makes very specific, very bold predictions. It's putting its money where its mouth is, so to speak. We can actually test it.
So how could we prove it, or even break it? Well, for one, when massive black holes merge, they send out gravitational waves. This theory predicts those waves should fade away, or ring down, just a little bit faster than Einstein's theory predicts. It also says black holes don't have an infinitely dense point, a singularity at their center. Instead, it's a soft core, which could create faint echoes that our instruments could detect right after a merger. These are real, observable things we can hunt for.
So let's bring this all home. What's the big takeaway here? The time force hypothesis is a daring proposal that suggests maybe, just maybe, the universe isn't a complex machine running on a bunch of separate, complicated laws. Maybe it's more like a song, with one single universal rhythm driving everything.
It leaves us with a pretty beautiful and powerful idea, doesn't it? That the universe isn't built on perfect, unchanging laws, but on a fundamental dynamic flow. And that a single, simple imperfection, this tiny universal friction, is actually the creative spark that allows all of the complexity, all the structure, and all the life we see to exist. Everything flows, everything damps, and from this, the universe lives.